Now let's look at the situation when we have a source of electrons or photons. So let's say it's a source of electrons. It's an electron gun. And again, we have the same sort of setup with a detector in the back here, which we can think of as, the screen in the back is fluorescent, so that whenever an electron hits, you get a little burst of light. And now we can ask, what's the intensity of the electrons arriving at point X? How much light do we see? How many do we detect? And the thing that happens here is that, well, one thing that you notice is as you turn down the intensity of the source of electrons, you start noticing that the electrons start arriving at point X at discrete points in time. So you see a flash, and then nothing for a while, and then another flash, nothing for a while, and so on. And as you turn down the intensity, the flashes don't get any less intense. What changes is the frequency with which you see the flashes. So again, what we'd have to say is that that would seem to tell us that these electrons are really particles. They are particles with, they are these charged particles, and as you turn down the intensity of the electron source, you have fewer and fewer electrons going out per unit time. And as they go out and they are knocked through, they are deflected through the edges of these slits, they randomly show up at some point X. And the probability that you see an electron here depends upon, as you turn down the intensity of the source, you see them less and less frequently, but they arrive as discrete objects, as discrete lumps. And so you can talk about the probability of detecting the electron at point X. You can call it its intensity, I of X. And so now we would, given that they are like discrete particles or bullets, what kind of behavior would we expect? Well, so again, if we open only slit 1, the intensity as a function of X looks like this. If you open only slit 2, the intensity as a function of X, the probability that we see an electron looks like this. And since electrons are behaving like particles, like bullets, you'd imagine that if both slits are open, you should see this curve, which is the I12, which is sum of I1 and I2. But in fact, what you end up seeing is this interference pattern, like we did in the case of waves. I12 is not equal to I1 plus I2. And that's the strange thing about quantum mechanics. So how could it be, if electrons are traveling, if they are like particles, if they are discrete objects, discrete, indestructible objects, how could it be that when both slits are open, you do not get to see the sum of these two curves as the probability of the electron ending up at X? And you could say, well, let's reason about this a little more carefully and say, well, clearly the electron was fired through this source, it went through this hole, it got deflected, and then it either went through slit 1 or through slit 2. And if it went through slit 1, it ended up at X with probability equal to I1 of X. If it went through slit 2, it ended up at X with probability I2 of X. Surely, if both slits were open, it should end up at X with probability I1 plus I2 of X. Because after all, if it went through slit 1, why should it matter to it whether slit 2 was open or not? And the answer is, we don't know, but when you do the experiment, you get to see the interference pattern. Now, in quantum mechanics, we have a way of explaining this. What we can do is we can say, well, actually, there's an amplitude with which the electron goes through slit 1 and ends up at X. and that amplitude is a1 of x. And actually the probability that we detect the photon at point x, I1 of x, is actually the square of a1 of x. And similarly, there's an amplitude with which it goes through slit 2 and ends up at x. And if only slit 2 is open, I2 of x is just the square of this amplitude. And similarly, if both slits are open, then A12 is A1 plus A2. So that the amplitude with which the photon ends up at x is just A1 of x plus A2 of x. And of course, the probability that you detect the photon then is A12 of x whole square. So this is just like the water waves case, where we had the height of the water wave and the intensity is the square of the height of the water wave. Except that there's no height here. So what is this amplitude? Well, we don't know, but this is how nature behaves. The electrons behave as though there was some amplitude with which it ends up at x. And this amplitude can be positive or negative, leading to this kind of interference pattern. That's the funny thing about quantum mechanics. That's how electrons and photons behave. So let's summarize what we've learned. So we did this double slit experiment 3 times in 3 different settings. First, we considered it where it was a source of particles or bullets, which we think of as bullets. Then we repeated this experiment with waves, with water waves. And finally, we repeated it with quantum objects, like with elementary particles like photons, electrons. So, of course, in the case of bullets, we had discrete objects. They come, bullets come as discrete chunks, as units. In the case of waves, the energy arrives not as discrete objects, but it's continuous. And as we saw in the case of photons and electrons, they behave discretely. They arrive in discrete chunks, which we think of as electrons, or photons, which are particles of light. So, discrete. In the case of bullets, we talked about the probability of arrival at x. In the case of waves, we measured the intensity or energy. In the case of electrons or photons, well, again we measured the probability of arrival, which we said is proportional to the intensity. In the case of bullets, when we had both slits open, we saw no interference. In the case of waves, we saw interference. In the case of photons and electrons, we again have interference. And this is the funny thing. So even though photons and electrons arrive as discrete entities, and we think they should have gone through either slit 1 or slit 2, we do get the interference pattern. And this is part of the mystery. This is where we have this strange behavior quantum mechanically. In the case of bullets, when both slits are open, N12 is N1 plus N2. In the case of waves, I12 was not equal to I1 plus I2. But what we had was that H12, the height of the wave, did add, and the intensity was the square of the height. In the case of photons or electrons, again, we had I12 is not equal to I1 plus I2. The probabilities did not add. But then we came up with this notion of an amplitude, which is just some invented notion, and said A12 is equal to A1 plus A2. And that the intensity or the probability is just the square of A. And I actually put the square inside absolute values because, in fact, the amplitude can also be a complex number, not just positive or negative.